Hello, today we'll be understanding the mechanism of AZT and HIV/AIDS treatment. A brief overview. AZT or zidovudine is an antiretroviral medication commonly used in the treatment of HIV/AIDS. It works by inhibiting the reverse transcriptase enzyme, a crucial player in the replication of the HIV virus. AZT or zidovudine, like I said, as aforementioned, plays a crucial role in HIV/AIDS treatment. When administered orally, its journey within the body involves a pivotal activation process. This initiation is orchestrated by cellular kinases, which are enzymes responsible for chemical transformations within cells. The first step unfolds as AZT undergoes phosphorylation, biochemical reaction where phosphate groups are added to the AZT molecule. This transformative process converts AZT into its active form, AZT triphosphate. This activation is paramount for AZT to exert its therapeutic effects. AZT triphosphate, now in its activated state, becomes a potent weapon against the human immunodeficiency virus, which is HIV. Acting as a nucleoside analog, AZT triphosphate competes with natural nucleosides during the replication of the virus's genetic material, disrupting the synthesis of viral DNA and hindering the progression of HIV. In summary, the oral administration of AZT initiates a carefully orchestrated molecular dance within our cells, where phosphorylation by cellular kinases serve as the key to unlock AZT's potential in the fight against HIV/AIDS. We're going to talk about AZT triphosphate formation. Upon oral administration, AZT undergoes a multi-step enzymatic activation process orchestrated by cellular kinases. The initial phosphorylation occurs twice, actually, resulting in AZT monophosphate and AZT diphosphate. The final phosphorylation event yields AZT triphosphate, the active form crucial for inhibiting the reverse transcriptase enzyme, thereby disrupting viral DNA synthesis and impeding the progression of the human immunodeficiency virus, HIV. This precise enzymatic cascade marks the journey of AZT within the cellular process, showcasing the transformation from its administered state to the highly effective AZT triphosphate. The orchestrated phosphorylation steps highlight the sophistication of AZT's mechanism and its pivotal role in antiretroviral therapy, exemplifying a targeted approach in combating HIV/AIDS. I'm going to talk about reverse transcriptase and HIV replication. In the realm of HIV replication, the spotlight shines on reverse transcriptase, which I keep on saying, which is the key player in the intricate dance of viral proliferation. HIV, a retrovirus, adopts a unique strategy, converting its RNA genome into DNA during replication. At the crux of the process is reverse transcriptase, the enzyme that catalyzes the conversion, transforming viral RNA into DNA, a crucial step in the virus's ability to integrate itself into the host cell's genome. This integration is a pivotal event, allowing the virus to establish a persistent infection within the host. The integrated DNA serves as a blueprint for the production of new viral particles, perpetuating the cycle of infection. By understanding the central role of reverse transcriptase, researchers aim to develop targeted interventions that disrupt the vital step in the HIV replication cycle, offering potential avenues for therapeutic strategies in the ongoing battle against HIV/AIDS. We're going to talk about specificity for HIV's reverse transcriptase. AZT's impact on HIV is intricately selective thanks to its unique target, reverse transcriptase. In the cellular battleground, AZT triphosphate competes strategically with natural nucleotides for a slot in the developing DNA chain, catalyzing by reverse transcriptase. What sets AZT apart is its specificity. The reverse transcriptase from HIV exhibits a higher affinity for AZT triphosphate compared to the host cell's DNA polymerase. This heightened affinity ensures that AZT is more selectively integrated into the viral DNA, disrupting the synthesis process and hindering the progression of the virus. AZT's precision in targeting HIV's reverse transcriptase underscores its efficacy as an antiretroviral agent, offering a nuanced approach in the ongoing fight against HIV/AIDS. I'm going to talk about the mechanisms of action. AZT's impact on HIV replication unfolds through a strategic two-step process. First, AZT triphosphate engages in competitive inhibition, vying for a spot in the developing viral DNA chain against natural nucleotides. This competitive edge allows AZT to be selectively incorporated into the chain. The second phase is chain termination. Once AZT is integrated, its absence of a crucial 3' OH group prevents the addition of the next nucleotide, bringing about premature termination of the viral DNA chain. This double-pronged approach disrupts the continuity of viral DNA synthesis, showcasing AZT's efficacy in hindering the progression of HIV. The competitive nature and chain termination mechanism make AZT a potent weapon in the ongoing battle against HIV/AIDS. Just benefits and considerations. AZT, a cornerstone in HIV/AIDS treatment, delivers compelling benefits by effectively inhibiting the replication of the virus, thereby slowing down the progression of the disease. Its mechanism involves AZT triphosphate competitively inhibiting the incorporation of natural nucleotides into the viral DNA chain, followed by chain termination, disrupting the continuity of viral DNA synthesis. However, achieving optimal outcomes requires a crucial consideration: strict adherence to the medication schedule. Maintaining therapeutic levels of AZT triphosphate in the bloodstream is paramount. Deviating from the prescribed regimen can compromise the drug's efficacy. Thus, the success of AZT in HIV/AIDS treatment hinges on a collaborative effort between the medication's potency and the patient's commitment to a disciplined treatment plan. In conclusion, we're going to talk about the impact of AZT in HIV/AIDS treatment. AZT, through its activation and selective inhibition of HIV reverse transcriptase, plays a crucial role in slowing the progression of HIV/AIDS. Ongoing research aims to improve antiretroviral therapies and explore new avenues for HIV treatment. Thank you guys so much. Have a good day.